quadruped rigging stuff that's in addition to what he covers in that class. So we're going to start off with a pretty simple one. Has he gone through the entire hind leg with you guys?
Yes.
I think
Doesn't
so.
do it right.
What?
I said yes, but he doesn't do it right.
What did he not do did he
Twist.
twist?
Knee twist is full leg twist
Okay.
instead of knee twist.
And
he
did
only uses 2 joint chain.
and did he do a pull vector on the ankle, or when you move like the leg, it kind of drifts behind? Okay, then we'll show off both of those things in addition. So
I set that up on libs and I was like, I don't know why he doesn't use this. This makes so much sense.
I'm gonna try and get a nice looking joint chain.
Wow, that's amazing.
That's gonna be
Put that on the calendar.
okay. So we're gonna start out with just a regular joint chain that's gonna be the spring IK. Spring, hip, joint, spring knee joint, spring ankle joint, spring ball joint, because that's actually the ball of your foot if you were a human. And we're gonna have to do spring IK solver. Missed a G. I'm sorry. It's IK spring solver. All this stuff is just setting up the plugin, and I'm not sure why it wasn't loaded. Okay, so now we can do IK spring solver. Is it still not showing up? Oh, I'm sorry. I have it set to Python still. That's why. It should have been working from the beginning. So we're going to create an IK spring solver from the hip to the ball. And you guys who have taken, so who here is actually in the non-human character setup? Okay, so pretty much everybody, or you've taken it if you're Ethan. So that one works for a joint chain that kind of has a zigzag pattern where it's more than three joints long. But then it only gets you a certain amount of posing with your leg. For example, if I were here, I might want the hip to be pointing out like this. What? It's a display thing, and I can just make it invisible if I want to. So to get those extra poses, we need the hip offset joint chain, which I'm assuming he showed you.
Yes.
Offset hip joint. Modify search replace spring with offset. And on that one, we're going to create a rotate IK handle from the knee to the ball and delete that extra effector. And we're going to make the hip offset hip a child of the spring hip. And then we're going to create a simple control, which I'll just make a circle. Freeze all. And make the two IK handles a child of the control. So now when I do this, everything follows along as if it were one leg, but if I were to come in here and rotate this hip, you can see that it gets me another solution from the hip to the ankle. And sometimes you'd want to be able to use that solution as opposed to this one in brown that just the spring IK gives you by itself. So I find that the easiest way to do that is actually just with an attribute as opposed to a control, because that way all of your posing for the leg is done through this one IK control. So I'm going to go modify, add attribute, hip offset, and I'm just going to directly plug it in to the rotate. Was that not one axis? of the rotate Z of the hip offset joint. So Windows General Editor, Connection Editor. And we're going to connect hip offset into rotate Z on the joint. So that way I can move this around, and then I can offset from that with the hip offset one. And this one's actually going at a nice speed. So that's like the first level of additional posing that we want for our IK hind leg. But then sometimes you'd want to be able to twist the knee out of this plane for a pose. So to do that, we're going to need another joint chain. So I'm going to name this one knee twist. Actually, I'm going to name it upper twist, just so we don't get confusion between like the knee joint and the knee twist. Modify search replace name, offset with up twist. And for this one, we don't actually need a ball joint because we're only twisting the knee area. We only need the hip, the knee, and the ankle joint. And we don't need that empty effector because that's just left over from when we duplicated it. So now we're going to take a rotate plane and we're going to go from the up twist hip to the up twist ankle and create this IK handle. And this IK handle is going to control where the ankle of that joint chain is. And we always want that ankle to be following along with the hip offset joint chain's ankle. So just take the IK handle and make it a child of that. And then of course we want the hip to be a child of the actual hip. So I'm going to take the hip joint, make it a child of the offset hip joint. So now when I move this, you can see that everything stays in a plane nicely because we put that IK handle in the right place in the hierarchy. But if I were to go off like this to the side, you can see that this knee twist joint chain doesn't follow along properly. This should be down, I'm sorry. Yeah, this one should be up here instead. So what I need to do is I need to select the knee on the offset joint chain and select the IK handle that we just created, and we're going to do constrain pull vector so that it snaps onto it. And we also have an issue down here, which is that this is where the spring IK says the ankle should be, but this is where the offset says it should be. So in order to get those to agree with each other, we just need to select the IK handle that the offset chain is using, and we're going to pull vector constrain it to the ankle on the spring IK. Does that make sense why we do that? I'm seeing like confused faces. So I'll go back to before we created either of those. So this is the current behavior that we have, where if everything is working in one plane, everything looks nice, and all the joint chains follow along with each other, and it looks like I only have the 4 joints set up. But as I start to move off to the side, this joint chain starts to separate from this one. And this one that I have selected is the spring ankle joint, and this one up here is the offset ankle. So I want the offset ankle to be matching up with the spring one, correct? So in order to do that, I'm going to take the IK handle that is controlling the offset joint chain, which is the one down here, and I'm going to pull vector constrain it to the joint on the IK one. So that way, instead of this IK handle just sort of pointing out into nowhere, it's going to be pointing at this knee, and that ankle, and it's going to lock. Does that make sense? It's just like a pull vector constraint on a knee. You want it to point at that control, but in this case, I want the IK handle to be pointing at this joint. Is that more clear the second time?
So it's the IK handle of the offset.
Yes, the IK handle of the offset, I'll actually name it. Offset, IK handle, and spring IK handle. I want to pull vector constrain from the offset ankle, I'm sorry, not the offset ankle, the spring ankle, which is here, to the offset IK handle. And when I do that, it snaps into place. And then you can also, let me see if I can get it to show up in the situation. Oh no, because we already did it. So I'm going to delete this pull vector constraint that I created. So now, if I move it around, Okay, so we already corrected it. I will go back to here and delete the IK handle so I can show the other problem that was fixed. Okay, I guess it's not going to show off the problem again. But you also need to do that on the IK handle you set up for the knee, because sometimes the knee might drift off just like the hip offset one did, and you want it to be pointed at the knee on the offset chain, right? Which is this sort of chain above it. Because the spring IK works first, and then you offset from it with the hip offset, and then below that we have the knee twist joint chain. Is that making sense so far, that we have the 3 levels of control that are following each other? And so now if I were to control the twist on this IK handle, it's going to twist the knee off of the joint chain. So I'm going to add an attribute to this foot. Just name it knee twist. And I'm going to connect it to the up twist IK handle. Windows General Editor, Connection Editor, load them both in, and we're going to connect knee twist to the twist on the IK handle. So now I can take this control, I can drag it around and everything works fine, and then I can take hip offset and it will offset the hip from it to get me a different pose, and I can twist the knee off from that one. So that's the first 3 levels. That we have the spring, we have the hip offset, and then we have the knee twist. But sometimes you want to be able to twist the ankle as well. So in order to do that, we need another joint chain. So I'm just going to duplicate the knee, the ankle, and the ball from a joint chain, because those are the only 3 that we need. And I'm going to rename them so they don't say spring, they're going to say low twist. What? Yeah. That's not how you spell spring. And you want this knee to be a child of the up twist knee, because that is the one that we're offsetting from. Does it make sense that we have to have them in that hierarchy, because that's like the order that we're controlling them in? And so for this one, what we need to get this joint chain to twist is we're going to put an IK handle from here to here, and so when we twist it, it's going to move that ankle. And I'll show what that looks like just by itself. So we create the IK handle, and if I use the twist, it twists the ankle. So I'm going to name this low twist IK handle, and because it's located down here by the control, we're going to parent it to the control so it moves along. So now if I were to move, everything should look hunky-dory, except if we do that. And from what it sounds like, this is where Schindler stopped. He didn't show how to get this to match up with that.
Oh, before that.
Before that?
Yeah, you didn't do the separate element chains for the knee and the ankle.
Oh, okay.
So the secondary is what's rotating the ankle, and that's the twist on the secondary chain. And the primary is
Twisting the whole thing?
to the secondary and twisting the whole way.
Okay, so this is going to give you more posing. So in order to get this one, which is the low twist chain, to match up with the spring one, all we have to do is select that joint on here, which is the knee twist ankle, and then select the IK handle and do a pull vector constraint just like last time, and they're all snapping together. And now we have what looks like just a single joint chain, but it's actually multiple joint chains on top of each other that allows us to do a hip offset, allows us to do a knee twist, and let me add an attribute so I can control the ankle twist without going into the actual IK handle. Grab that.
Primary or secondary, or does it matter?
I didn't hear the question.
The ankle twist pull vector, is that going to the primary or the secondary, or does it not matter?
It is going to the ankle on the knee twist.
On the knee? Oh.
Yeah. Because that is the one that is one level above it. So we're going to ankle twist into twist on that IK handle. So now can do the knee twist, and then off from that, we can also get the ankle twist. And this setup is actually necessary if your model, for whatever reason, doesn't have their hind leg in a single plane. Like, let's say their knee is sort of offset from that plane on the actual model. Oh, did I break something? Oh, I did. I selected an IK handle instead of the control. Then you'd have to set this up, and you would just twist off the knee into the correct pose before you bound the skin, and you could either leave the animator with just, say, -25 when you want it to go back to the bind pose, or you could go into the node editor and say whatever value they put in, like if they put in 0, make sure -25 is what's plugged into the twist attribute on the IK handle, right?
The way you said that was like, make sure that what the animator says just is not what is happening.
Well, no, because like the animator would
add something, right?
Yeah, what the animator would expect is that when I put this to 0, it goes back to the bind pose, right? Just sort of the static pose. But if your character has their knee tilted out slightly in the bind pose, then putting this as 0 is going to make the leg in a straight line, in a single plane. So it would be unintuitive for the animator to put -25 here. So instead of doing that, you would just take the value that you have on this control, subtract 25 from it, and then plug it into the IK handle twist, so that when they put in 0, it plugs in -25 to the IK handle, and it will look like this. Does that make sense, how you'd offset that? Does it, Noah? Okay. So now we have the hip offset, we have the knee twist, and we have the ankle twist, and everything works nicely. In terms of what you'd be binding in this case, we're going to be binding the low twist ball joint, because that's the lowest one that we have like all the control over, that ankle, that knee, and then we don't actually have a hip for that joint chain because it's just the lower 3, so we're going to grab the up twist hip, since that's the hip lowest in the hierarchy that actually exists. There isn't a low twist hip.
Those are our bind joints.
Yeah, that's what you'd be binding. Yes.
Judging by my own experience with this, I'm going to guess that when you stretch it out to a fully outstretched position, it will flip.
Well, let's find out. Display, transform display, local rotation axis.
Mine personally wasn't on the that chain.
Yeah, so I will.
Mine was on the bind joints.
Okay, so 1, 2, 3, 4. Let's find out if this is flipping. So this one flipped. Let's see where that flipping is happening. We're troubleshooting Haley's problem live. So this is the spring IK, and the spring IK isn't flipping because the orientations are staying the same. Hide those. Offset one isn't flipping. Let's try the up twist one. Up twist one is not flipping either. And then we'll try the low twist. So it's actually this joint chain. So why would this be happening? We have an IK handle.
What's the pullback on that one? Is that the...
It is going to the offset. Sorry, it's going to the up twist ankle. I'm going to see if changing that to the offset ankle fixes it, since they're both going to be in the same place. Offset ankle to... Did I delete the IK handle? I did. Just delete the pull vector. Offset ankle, low twist IK handle, constrain pull vector, which will look the same. And it's still flipping. So it is flipping because this guy's aiming at a joint that's right there. Oh, wait a second. It didn't flip when I just... No, it did.
No.
If you did what?
What if you took the values for the pull vector, you put those in, and then you changed the one that was making it flip? Which I found to be Z, I think.
On here?
Yeah.
So this one is trying to aim in positive Z, but we should want it to be aiming in negative Z. So it is trying to aim at a point out here, but we wanted to aim at a point over here. So we can set up a condition node to when the leg is fully stretched out, it will flip what that pull vector value is. But would that work in every case? Like if I were out here or I'd flipped it all the way around, I don't think that it would.
You say if you had. I'm thinking because I have a stretch limit attribute, so you said saying.
Well, I'm saying that it's not as simple as plugging in a different pull vector value because depending on how you are oriented in world space, it might not be the Z direction anymore.
Could you put a locator that's following that angle, but slightly off to one of the directions, and then parent it? Follow me.
If you were to do something like this, parent that to the eye. If we were to do that, that seems like it will work out. This guy to this guy, constrain, pull vector, does that flip. Okay, so that seems like it worked. Oh, is it? No, because it's not aiming at the ankle anymore.
What if? Well, yeah. What's that parent kid or what's that child up right now?
The up twist angle. The thing is that we have to. It has to be
In the same exact.
pointing along a vector that goes to here. I'm wondering if just because I've never run into this problem before using this setup. So let's say if I just put the locator there, does it still flip?
What if you move the locator from here? It looks like it's backwards now. Wasn't it pointing the other direction? No? I thought that was the final twist. That was where it's supposed to flip around. Right? It's backwards.
What?
It's the Y orientation, or the orientation of the joint is flipped. Because when you're getting the non-flip, or the no-flip right now, it's in the position of the flip. It's just not flipping because it's finalized and thus it's.
Are you talking about this ankle joints orientation?
Yes.
No. This is what the original orientation
That
was.
is the original orientation?
Yeah, because
Okay.
it was X primary Y up.
Okay.
So this may be as good as you can get, that you'd want it to be just not quite on the joint chain that it's pointing at. You'd need to like tweak it out ever so slightly. And that should solve the flipping issue. Yeah. And it may have something to do with the proportions of the joint chain of it running into that buggy issue. But I would say that this is the best solution, just to create a locator that is a child of that ankle and just tweak it off slightly so that it doesn't run into any potential issues using the pull vector to align all the joint chains. Sorry that we had to solve that problem on the fly, but it happens. Okay, so I'm going to save this. Just my documents. Hind leg rig. Is it actually saving? It is. Okay.
Is that the ankle twist hiking handle?
you were going to create a locator that is a child of the
Ankle twist.
knee twist angle. Yes, and you're going to tweak it slightly off in whatever direction it would be aiming in. And it doesn't have to be like 1 unit, it can be like 0.001 unit.
To which pull vector? We have a few icon handles now. Or to which pull vector to which ankle?
The locator is the pull vector constraint target of the ankle twist IK handle. Does that all make sense so far? Showing off this variation of Schindler setup so you have a little bit more control. The issue that this one has, though, is that if I were to bring this down to try and make it stretch, and then I had the hip offset on, the hip offset is always going to offset from the joint chain by a certain amount. You'd expect the hip offset to also get straightened out when you pull the leg this far. So the way to solve that would be to come into the node editor here, and we're going to do the setup as if we were going to make it stretch, but not actually put in all the stretch values. We're going to create a distance between node. Actually, I'll create it in here because it's a little bit easier. Distance tool from here to here. Put one on the hip. Put one on here. And then I want the actual length of the leg right now. And the fastest way to do that is to create a linear curve. Snap one to the hip, snap it to the knee, snap to the ankle, snap to the ball. And just use the command arclen to get the length of that curve, which is this long, 16.42 units. And then we can delete that curve because we don't need it anymore. And what we want to happen is when the distance measurement node returns a value that is greater than that 16.42, we want the leg to start to stretch, correct? So I'm going to come into the node editor here, and here we have the distance node. We're going to create a multiply divide node, and we're going to divide this length by the rest length, which is the total length of the leg, and I'm going to set it to divide. So right now this is going to return something that is less than 1 because the length between the ankle and the hip is less than the length of like sort of the zigzagging path that the leg is making right now. That makes sense. But if we were to stretch it out like this, then the length from here to the control would be more than that original length of the zigzagging leg, correct? So when this division value, like it is right now, is greater than 1, that's when the leg should be stretching. So I'm going to create a clamp node, and I'm going to take the output and plug it into here. And I'm going to clamp it so that it never returns a value that's lower than 1. So if that ratio is less than 1, as it would be here, because you see we're dividing the distance from here to here, which is about 8, by this distance, which is 16, it's going to give us about 1/2. But we want it to return 1 because we want to keep each joint on the leg at its original length. We don't want it to get scaled down by 1/2. So we're going to clamp it and say the minimum is 1. So it never squashes, it only stretches. And for the max, I'm just going to set it to 100 because we need it to be something high that the animator will never be stretching the leg that far. Now, I'm going to get it into the problem area, which is that the hip offset causes problems. We want the hip offset to be straight with the rest of the leg when we start to stretch it. So I'm going to bring in this control so we can see the hip offset connection. So let me drag these guys over. So this is the hip offset connection. We have hip offset coming down here to the rotation on the hip offset joint. And what we want is when the ratio of the length from the hip to the ankle is exactly equal to 1, we want that offset ratio to be set to 0, so it isn't offset at all, it's straightened. So to do that, we're going to create an anim curve, which is just like set-driven keys, but you can set it up in the node editor. and we're going to set some keyframes. And the easiest way to do it with these guys is actually with commands instead of set-driven keys. So I'm going to do set keyframe at time 1 and value 1, and then I'm going to set one at 2 and 2, just as some filler values, and they should show up. And I'm sorry, it shouldn't be time, it should be float. So now we have a node with 2 sort of keyframes set on it, and you can see them over here in the attribute editor, or we can look at them in the node editor. We're going to shape them in the node editor because it's easier to understand. So when that clamp node is returning 1 when the leg is completely stretched out, we want the hip ratio to be multiplied by 0, so it returns 0. So we'll say when it's 1, set it to 0. And then when the ratio is less than that, we'd want it to be just at 1, that it keeps the regular value. So let's say at 0.5, at 0.5, we multiply it by 1. And this might be sounding kind of confusing, but once I plug everything up, hopefully it will start to make more sense. So we're going to take the output from the clamp node, which is never going to be less than 1, and we're going to plug it into here. And then we're going to multiply the hip offset value using a double linear node, which is the same as a multiply divide node. It just does it for 1 value instead of 3 by the output from this. And then we're going to plug that into the offset. We don't need that anymore. So now, hopefully you can see what is happening. So when everything is just normal, I can come up here. I'm sorry, did I not plug it in correctly? So when the ratio is less than 1, why is it returning 0? Tangents for infinity constant. Because this guy's outputting a 1 into this. Oh, I'm sorry, we have to take it from this one, not the clamped value. So output from here needs to get plugged into the anim curve, right? So the input for this one. Okay, so that is working properly. So right now, hip offset works as you'd expect it to. And as we bring this down, this value is going to get closer and closer to 1, correct? The ratio between the length from the hip to the ankle and sort of the original length of the leg is going to eventually become equal to each other when the leg is completely straightened. And what's happening with this node is that it is taking that value that's getting closer and closer to 1, and it is changing it so that its output gets closer and closer to 0. So when we finally get to a completely straightened leg, it is going to be multiplying the hip offset value that we set on the control by 0, so the hip isn't actually offset by anything. And so when we finally get down, you can see that it starts out offset by, I'll actually set it to a recognizable amount. I'll say it's 90 degrees, which is a lot. As I bring the leg down, you can see that the offset between the hip and the hip offset starts to decrease. They get closer together until eventually, when we get down to a completely straight leg, they're the same. So that solves the problem of stretching while using the hip offset joint chain. Was that clear? I know there was some problem solving in the middle. Is there anything about this that was unclear, or?
What's an anim curve node do again?
An anim curve node is the same thing that's created inside of Maya when you do a set-driven key. So in this instance, what the driver for the set-driven key would be the ratio between this distance measurement and the original length of the leg. Okay, that makes sense. Okay. Yeah, there are multiple kinds of anim curves, and I usually have to look it up whenever I do it. But like anim curve TL takes a time input and gives you a value output, and then UU just takes any input and gives you any output. So that's what I usually wind up using. The only difference is sometimes it will create like a unit conversion node on one side or the other if you didn't use the right type of anim curve. But if I were to just search my anim curve node, you can check it right here. It says like, yeah, anim curve TL plugs in a time, gives you a distance. Anim curve UU, you plug in a double, which is basically any float attribute, and it gives you any float attribute as the output. So that's just a way to quickly check if you aren't sure which one you're supposed to be using. So now we've gone through fixing the ankle follow issue, and we fixed a pull vector issue that happened to occur with this leg. Stretchiness and a hip offset, we just showed you how you would solve that. We're going to move into a slightly different variation on the ribbon spine that can get you posing a little bit faster. Yes?
I have a weird thing happen. When I switch from IK to FK, one of the legs is totally happy with it. The other leg is doing a full twist.
I would check the orient constraints to make sure that they are in no flip mode. That would be my first guess. So I will also save this.
Is it mode or no? What?
Select the orient constraint
Okay, hold on.
in the outliner. It should be right below the joint that is constrained, which would be the bind joint chain.
Fine. If, right. Okay, here is one of my orients. It's the knee that's flipping. It's average. But it's no flip?
Yeah. And see if that fixes it.
I did not know that existed. Still flipping. Flipping more.
Flipping more.
Flipping more.
Okay, I'm gonna have to take a look at it later. So that's basically everything for the hind leg, and I'll show you a slightly different setup for a ribbon spine that you might find more useful on your character. So I'm gonna quickly create a ribbon spine. My goodness. So length ratio, create some patches. And we're gonna create all I want is a joint. Some driver joints for it. And typically, you would have the 3 driver joints skinned to this single one, right? And then we would have 3 controls set up. It's all.
Okay, so you're gonna. It doesn't flip if it's anywhere besides 0. If it's zeroed off, it flips. If it's not zeroed off, it doesn't flip. And the nice part is, I don't think anyone's gonna be switching from IK to FK into the animation when it's 0 pose.
Well, that's not exactly a nice thing.
I think that is a nice thing.
That's a completely neutral thing.
I think that's a nice thing.
What if they want to start in FK?
Then they can switch it before. Why would they start in IK and then switch it in the animation?
Okay, so on a regular ribbon spine, you have the 2 controls on the end that are bound to the curve, and then you have one in the middle that's also bound to the curve. And the way that Schindler shows you setting it up is you have kind of a group above that middle control that is point constrained to the 2 of them, so it's put in the middle. So that way, when I lift this one up, this one gets lifted as well, and then you also would aim constrain it at one of them so that it properly orients. Constrain aim, apply. Oh, that's not right. I needed to aim along its z-axis. Aim vector would be z.
Never mind.
Okay.
I fixed
So this is what he showed you, right? That you have the one in the middle.
Yeah.
Yeah, it actually had two locators on the mid, and then one is pointed at the chest, one's pointed at the hip, and then
So that it rotates. Yeah, you got that, and then it.
Yeah. The thing with that one is though, it's always going to be somewhere along a straight line in between those, correct? Because you have a point constraint set up, which averages the position of them. So aiming at one is the same as aiming at the other, because you're just aiming along a line. The two locators that you have set up are going to be just aimed in opposite directions. So when you average them, it's just going to be, yeah, it doesn't matter. If you're setting up a character that has like a really curved spine and you do like a different setup to get it in the middle as opposed to just a straight point constraint without a maintain offset, then you may need to do the two locators, but
like a serpentine kind of character.
I'm thinking like a warthog that might have like a really arched back to it where the joint chain you want it to be higher in the body, right? This is mathematically making sense why you just need one. So if you already set it up with two, just keep it at two, but be aware that it isn't always the case. And what I'm going to show you is an alternative method to do either of those, which can get you kind of better results. What you might expect, like let's say I have a cat and I take its shoulders controls and I kind of tilt them down, and then I take its pelvis controls and I tip them up. You'd expect the spine to kind of make an arc, right? That I'm taking it and I'm doing like that, and you want to make a C shape. If I were to do that with this just stays in the middle. It doesn't move up automatically to create the curve. But there is a way that we can have it do that. So I'm going to delete the point constraint and the aim constraint, and I'm actually going to create a second ribbon. And I'm going to bind just this one and just this one to that ribbon. So now if I were to take these two controls, this third ribbon makes the shape that I want that control to follow along with, correct? That C shape. So all we have to do is get this control to stay attached to that ribbon, and then we get kind of better automatic placement of that middle control. So to do that, all we have to do is create a follicle on that second joint chain. So I'm going to name it rider joint chain. I'm sorry, rider ribbon, because that is the ribbon that the middle control is riding on. And I'll name this one bind ribbon because it's the one the bind joints are going to be riding on. And we're going to create a follicle on it. And hair, create hair, 1, 1, apply, and delete all this other crap that you don't need. And we are just going to point constrain this parent constrain the buffer group that it is above this control. Sorry, did I muck something up briefly? Yeah, this guy should be in here. I guess I didn't zero off the control. So zero that one off again. So we're just going to take this control, and we're going to take the buffer group above it, and we're going to parent constrain it to the follicle on that rider curve. Constrain parent. So now, when I do this, and I do that, it stays in more of an arced path, and that second ribbon, the one that the bind joint chains would be along, also gets that same path. So that is, in my opinion, a little bit more helpful to the animator because it automatically places the middle control where they'd expect it to be. So that's a pretty easy setup, and it also works with twisting, that it kind of gets half the twist from each of them. Can work even if you want to like flip your ribbon completely upside down. And it's just another way to put the middle control in the middle. And it's a way that I think is actually better than just the point constraint and the aim constraints. So I will save this as well. Save scene as alternate ribbon. Spelled ribbon wrong, but it doesn't matter. And we'll go back in here and see. So that's the ribbon spine. Now we're going to be talking about digitigrade and platigrade switching. I don't think anybody's doing a rig that would require this in their class. Was that like a raised hand tentatively or just a stretch?
I was just thinking it through.
Yeah, because like animals that would be doing that would be like a bear in very limited circumstances or a kangaroo, and I don't think Schindler would approve somebody rigging a kangaroo in quadruped.
What about a dragon?
Depends on the dragon. Would your dragon be walking with its heel on the ground sometimes, and sometimes walking with its heel off the ground?
No, it's a wyvern.
Okay. I don't know if those two things are mutually exclusive though. Being a
I was
wyvern.
wondering whether you'd ask.
Okay.
I don't know if that was justification or just me. Just telling you another fact about my dragon.
Okay.
It's red.
It's not red, actually.
So
It's a lamber.
I'm gonna show. No, that's not a good joint chain to show this off, because that wouldn't keep the heel on the ground. Go from here to here to here to here. So that's just a joint chain that we're going to create the leg on. And I won't go through the whole process of creating another hind leg. I'm just going to do a spring IK solver and nothing else. So that is what it would look like if it's a digitigrade, like a dog and it walks and its heel is always off the ground. But let's say I have a kangaroo, and sometimes kangaroos
Well, picture kangaroo, yeah, probably.
stand with their heel on the ground or walk with their heel on the ground, as well as hopping where just this section would be on the ground and this section would be up in the air. I'm trying to see if I have a better, yeah, that's a better hopping picture. So you can see how just this part would be on the ground and the heel would be off the ground. Now you could try and just say, animators, you got to do it yourself, try and place that heel somewhere so the heel's on the ground. But that's not going to be very good, because if the kangaroo happens to be sitting back on its heel and it moves its hip, that's weird. Why is it moving the IK handle? That's so...
I can't handle it. It's just floating in space. It's not going to impact anything.
Oh, that's right. I'll parent that to that. So then if it were to move the hip, you can see the ankle is no longer pinned to the ground, because it is set up to always move when you move the spring IK. So going all the way back to the original placement of it. So a setup that would let you pin on the ground is just kind of the regular platigrade, which is like a human or sometimes a rabbit, where their heel is always on the ground. To do that, you just have a rotate plane solver, which would go from here to here, and then this would be like the ball of your foot. And we create a locator here to rotate it like that. And this should be pretty recognizable, because it is basically what you would set up for a regular biped, just a human, where you have the knee and an ankle and an IK solver going between them, and then you'd have to have a single chain one going between these two to keep the foot in place. So that's how this one would be working. Sorry, I grabbed the wrong thing. How you see how these two never really rotate again away from each other. They always stay as kind of a fixed segment. So that way, I could rotate the heel down onto the ground and still move the whole foot as if it were flat, or even come up to here and grab the hip. And when I move the hip around, the heel stays on the ground, which is exactly what you want on a kangaroo rig. The problem with that is switching between the two, because you can see how we need to find with an IK solver a solution between the position at the hip and the position at the ball. And so this is one valid solution, and with the heel on the ground, this is another valid solution. And I'm going to show you the problem. If I were to, I'm going to write a quick script, which should only take about a minute or so to show you it. We're going to create blend color nodes to just try and blend between them that way, and you'll see why it doesn't work. So plat equals ls-sl, $sign digit equals ls-sl, for $i equals 0, $i is less than 3, $i plus plus, blend equals create node blend colors, connect adder.
That's what we do just in this section. So it seems like you typed super
I mean, I am typing pretty quickly.
Even faster, so they're just like, where's this person?
Color 1. You can see the code. Okay, it's right here on the screen. What do you know, Noah? I can say whatever I want. So we just created a blend color node. We're going to connect them into it for each joint, and then we're going to need to connect just an empty attribute into the blender. And I'm just going to make that attribute the translate Y of this locator, because who cares? History output mel. So we're going to connect that attribute into the blender. Connect adder, translate Y from that locator into the blend node, blender. Okay. Select this one that we want to blend. Select this one that we want to blend. And I actually need the third one. Dash SL. And then we need to connect the output from the blend color node. Assign blend plus output into, because I spelled bind wrong up at the top, so I have to spell it wrong here. Bind $I. What? Yeah. And run it. Okay, so looks like the script ran properly. And so you can see, as I'm blending between the two joint chains from 0 to 1, the heel is going to drift off. I'm actually going to set a min and max on this locator so we don't break that node. So this one can only go from 0 to 1 now. So when it's at 1, it's 100% with the spring IK. And we come down here to try and pin it with the ankle, you can see that the ball here is drifting off. And that's just a consequence of like the mathematical fact that taking the average of these rotations that give you two valid solutions between the hip and the ball, the average of the two is not a valid solution. So we can't just use blend color nodes or orient constraints to blend between the two. But what we can do is create a third joint chain and blend the first joint from each of them. So that would be the hip joint for the spring IK, the hip joint from this one, and plug them into the hip joint on the blending one. And I'm going to turn off maintain offset. And then we're going to create a rotate plane IK handle from the knee of that blending joint chain to the ankle and put it down here. And I'm going to parent it to the locator so it just stays in place. Now, if I were to come under the orient constraint, which is now the only thing that we'd have to be blending on, and blend on it, you can see that the ankle is staying in place because the rotation blending happens up here with the orient constraint, and then the IK handle just sort of solves what the other two rotations have to be to get you a valued solution. So does that make sense as a way to solve that? That you can just combine an orient constraint and IK handle to get you interpolation.
And you could do the same thing when you're blending between IK and FK arms.
Kind of. I came up with this, or at least I found out about it when I was working on a film where the character needed to switch from being digitigrade to platigrade because it was a dragon that actually walked like a kangaroo. But then I also used this same technique on my arm rig because if you can imagine, you have a regular arm which you're blending between with blend colors. So you have your FK version and then you have your IK version. If I wanted to connect a hand to that arm rig, you'd connect it to the wrist, correct? So the hand is going to move along with your bind joint chain. But let's say I want to have a control where I can lift the palm of my hand up like this, but keep the hand in place. In that instance, you'd be controlling the position of the hand with the arm, but you'd be controlling the position of the arm, or at least the wrist, with the hand, which seems like a loop, right? because you control the hand with the arm, and you control the hand with the arm and the arm with the hand, which doesn't work. So what you do is something similar to this, where I control the hand with the bind joint chain that is just driven by blend color nodes, and then I have a third joint chain, which is just another IK handle, and that one is the one that is being driven by the wrist. So it just lets you offset from the other bind joint chain. Does that make sense? That's getting into like a different thing, but that's another place that you could use this technique of putting IK handles on your bind joint chain to get a desired behavior. You seem a little bit blown.
There's a couple pieces that I don't understand. I see how this is going.
Okay. Is there like a specific piece that you want to ask?
Blend color exactly.
So that's what I set up with the script in here. With a blend color, I'm sorry, that's the wrong selection. So I'd written a script which basically plugged in the hip joint from one joint chain, the hip joint from the other one, and took their rotations. Let me just show with one blend color node. So I took their rotations and I plugged them into a blend color node, and it's called a blend color node, but basically what it does is it takes any three inputs and it blends them with a set of any other three inputs. So in this case, I put in rotate X, rotate Y, rotate Z from each of them, and then I had a locator, just acting as the blender, and then I'm taking the output from that and plugging it into the hip. So that's how you do like an IK FK switch. You could do it with an orient constraint and kind of change the weight of them, but in this case you blend the rotations.
It kind of averages the ones.
Yeah, so the blender, I'm gonna turn back on the joint chain so you can see it. So this is what the blender looked like. This is what the joint chain looked like when the blender was set to 1. So it's 100% weighted to one of the joint chains. But if I were to come down here and kind of slide the blender, do you see how it is switching the rotations? So that's what a blend color node. It basically lets you blend inputs. In this case, we're using rotations. So that is how you would go about rigging the hind leg on a kangaroo. That's kangaroo. So we went through that, and we went through that, and we went through that. We can talk about segment locking, which, again, I don't think anybody in your class for non-human is going to be running into this problem or need the functionality, but I'm going to pull up the demo for it. So this is sort of the demo from a guy called David Ott, who he didn't work at DreamWorks, but he worked at a VisFX company that did some of the technical work on DreamWorks films, and so he's showing off the IK leg setup that he developed for Madagascar, and it's the same setup for every character. So you can see that he's overlaid kind of where the joints would be on each of the rigs. And so, yeah, so even like an elephant, which has a very different setup, it's still using the same rig, but just with different settings. And so at the end, he's going to show off what the rig is for. And basically what the rig is for is that Marty, let me find a single frame where he's actually doing it. Marty is a zebra, so when he walks, it's tough to get a frame of it. Do you see how his front leg like bends in the midsection? Like if you were to do it, it would be like having an extra joint here in the middle of your forearm. Because this is actually not his wrist, this is more like his knuckle. But as soon as he starts acting like a biped again, these two segments have to lock together and it has to look like he just has a regular elbow again. See how he no longer has that extra bend in the middle? So what David Ott is going to show is he's going to show the rig that lets you do that. And so you can see that it has a setup which is basically acting like a spring IK. And then he has a version where he locks two of the segments together. Then he has a version where he locks the other two segments, which would be kind of just your elbow acting as a single forearm. And then this one, he shows off some pinning that would go along with that setup. So I'm just going to show off how you would do it on like a horse that you want to lock the two upper segments. So I'm going to just blow everything in the scene up. And we're going to need to create another joint chain. I just want that nice. So we're going to have a spring solver. And then we're going to duplicate the joint chain to create the locked version. And so what the locked version has to have is, instead of having 3 joints, it's just going to have the 2 because they're locked together. It's acting as if it were 2. So I'm going to delete the last one. And then what we have to do is we have to set it up so that this first joint segment matches the one on the spring IK, right? But then this second joint chain is going to have to be longer because it has to be the sum of the length of these two, correct? Because when they lock together, it's going to be like their 2 lengths have added together. So the easy way to do that is let me just see what their translate x's are. So translate x on joint 3 is 4.243, and for this one, it's also the same. So I'm not going to bother with math. 8.486, that's what the 2 joint segments added together would be. And so we're going to need to make the translate value of this joint that. So now you can see how it needs to be longer because it's the sum of these 2 lengths. But then of course we need this one to look like a valid solution between the hip and the ankle. And it's a pretty easy way to do it. Just create a rotate plane between the 2 and snap it onto there. And so now you could see if I were to take this joint chain and blend it so that the hip matches this one, it would look like I've locked the 2 lower segments. So to do that, it's pretty much the same as on the other rig. We would just need a 3rd joint chain, and we're going to create a rotate plane from joint 2 to joint 4, and then we're going to do a orient constraint between the 2 hips, just like we did on the kangaroo rig. And I need to make sure that IK handle stays in place, so I'll just parent them all to a locator. So now you can see how we can lock the leg. So I could move it into the locked version and it will still move around properly. Then if I want to unlock it, I can just come back in, and you'd set up control instead of having the animator change attributes on an orient constraint. But I can blend between those 2. Does that make sense as a way that you could do that? I don't know if anybody is planning to make a film with a bipedal horse or a zebra, but if need be, this is what you would need to do. And so with this setup, you can also now introduce knee locking, because this, because it's 2 segments long, is basically the same as a human's knee, where there's just the hip and there's just the shin. So has Schindler talked about knee pinning in any of the classes that you've taken? Okay. So I will just show you on this joint chain, this 2 segment one. So I will create a locator out here, pretend that it's the pull vector control. Actually, we'll make it the pull vector control by grabbing that locator, that IK handle, constraining them. So basically for knee pinning, we want this thing to stretch out so the knee is always on that. So to do that, we're just going to create distance measurement tools from here to here. Unfortunately, it did a weird snapping thing. And I'll create an actual control there instead of just having to drag around those locators the whole time. And what we want is we need to plug in this distance into the translate x of this joint so that it's going to get take the hip and it's going to translate out 8 units, which is exactly how far it would have to be in order to get to this pull vector control. And then we're going to need the second joint to have its translate x value blend towards 11, which is going to get us directly from here to here, because that's the distance it has to be. So let me go in to that joint chain. I'll actually hide the other two. And we are going to go in and take the two distance measurements and take the two joints that we have to plug them into, which would be this knee one, because we need to increase its translate value, and the ankle, because we also need to increase its translate value. So we'll bring those guys into the node editor. And I'm going to create a blend 2 adder, which is the same as a blend color, except for instead of blending 3 inputs, it just blends the 2. So you would only put in 1 value. And so what we want to blend between is just kind of what they start at, which for this one is 4.232. Oh, it's going to be wonky. So one input is going to be from distance, but then the other one it's going to make it disappear. The other one needs to be from the distance measurement node. I'm just trying to break this connection here. But it's not keeping. No, because it doesn't show up in the channel box. I'm just going to create a node that is going to hold those values. So I'll set input 1 to that value just so I can do it as a connection. So now we're blending between the original length of the hip, and what it needs to be to stretch out to the knee. And actually I plugged in the wrong distance. I plugged in the second one. And then for this one, we're going to have to take this translate, which is 8.486, and plug it in as an input on this blend adder node. Take input 2, and plug it into here. And then we're going to take the second one, which is the distance, plug it into here. And we are going to take the outputs and plug it in as the translate x's on these guys. And then I'm going to just create I can actually just do the blending by hand. So now you can see that right now both of the blenders are set to 0, which just means we're using the original length of those two joints. But now, if I were to select them both and change the attribute blender to 1, should max at 1. You see how it's stretched out to there. And even if I were to move, we have a snapping thing on, this control around, the knee still snaps to it. And so you can imagine that we have this setup that was blending the rotations between the two to create the locked elbow. All you'd have to do is create a node network that also blended the translate values instead of the rotations, so that it would also stretch out to there. Does that make sense? We covered a little bit of this when we did like the leg rigging and the arm rigging last quarter. So this is a little bit of a refresher of that. So that's a way that you could lock the elbow and also have knee pinning on a bipedal horse. Or maybe you have a character that needs it for a different reason. Like I could imagine that in the video, the elephants might have used that functionality more, because elephants don't really have a lot of bend to their legs. So it may have been that they needed to lock them out at some points. So that was everything that I had written down for things that were in addition to Schindler's quadruped stuff, because you guys have pretty much finished with it. Are there any things that were unclear when Schindler went over it, unclear when I just went over it, or things that you're running into on your rig or you might want to implement on your rig?
What about front leg setup quadruped? Currently I have it set up that when I move the body, but not the IKs of my front leg,
Um,
That makes sense.
You see the whole pattern with it?
Yeah, I've done the cloud
Did you
design.
make sure that the line was parent of the first part of the platform?
Yeah, those parts are good with it. It's those are the
Oh,
forearms.
did you make sure that the control is a child of one of those that will with it, and then that the control is a parent of all three of the following? The eye can handle, like one eye can handle a fine joint and the shoulder. That's the part.
so it sounds like Haley might have known what your issue was. Is that true?
Yeah.
Okay, yeah. I mean, yeah, you can pull it up and we'll take a look. Other than that, anything?
And the ribbon spine setup you showed us support multiple points of articulation than just the three controls.
Yes. So you could create 2 follicles on that rider ribbon and have them both ride along with it and then use them to both control it. So instead of having 1 control in the middle, you could have like 3 or just 2. Especially if your character has like a long spine. Like if you're doing like a Chinese dragon character, you'd probably want more controls to create more of a curve in the middle. Sounds good.
So do you.
So I guess that's everything that we had planned for the demo, and nobody else has any questions or things they want to go over. So
Without you.
now the demo's over. Get out.